Hi there. Good afternoon, everybody. Good evening for some, I guess, depending where you're watching from. Happy to digitally meet you guys. Hope you will have also some questions for me afterwards, after my presentation. Um, I will be talking about low-cost construction with Holocore elements. So it's mainly going to be a focus on Holocore. In South Africa, there is a big knowledge about Holocore, as some of you may know. So it is a known product, definitely over there. To start off with, what is my company? We are Echo Precast Engineering. We're based in Belgium. We are mainly designing and manufacturing machinery and equipment for the production of pre-stressed concrete elements. So that means that we produce Holocore slabs, but also other pre-stressed elements on long beds. We supply the complete solution for the factory. So that means that everything except for the factory building itself, we can supply to you. So all the machines inside, but we also do the delivery of the equipment. We help you start up the factory with the commissioning. We can also give you training on site, which we normally always we include then the training on site. We help your guys to know how the machines have to work. We also have an after sales service, of course, and there are spare parts on all of these machines. And we make a complete range of machines that go from a standard 1.2 meter. For the Russian market, we have 1.5, which is standard, but also a very popular choice more and more is 2.4 meter wide machineries, who can either produce a slab of 2.4 meters wide or 2 times 1.2 meters wide on one single bed. Lifting equipment, tension equipment also is in this package. So our company, we're based in Belgium. We're part of the Progress Group. The Progress Group is a European company. It's based all over Europe, actually. We have our headquarters is based in Brixen, Italy. We have also in Brixen, Italy, we have the other companies such as PMA, so that is Progress Machine and Automation. That is machines for rebars. We have our own software development company. We also have our own precast company. We then have in Germany a sister company called Ebawe. Ebawe supplies machineries for carousel systems. And then we have Technocom also still in Italy. I forgot of these guys. So Technocom is based in Italy. They make molds, battery molds, staircase molds, all sorts of molds. And then we have ourselves based in Belgium, near a city called Hasselt. So that's where Echo's headquarters is. So we started off in 1950. So as the machine builder for the Echo Group. So Echo Group was a company supplying its own machine, its own precast in the market. Echo Engineering became the machinery builder. And then in 1963, we were also the first to supply Holocore machined made on steel beds. So the basis now today is always on steel beds. 1990, it became a separate division, so a separate company. And in 2012, that's also the point where we became a member of the Progress Group. At that point, we had over 200 machines in operation, over 150 factories worldwide. So we are also having, the name Echo is also known in your country as a supplier of concrete. So what is a Holocore, a precast, a pre-stressed Holocore element? A Holocore slab, it's quite simple. It is a flooring system. It is industrial product, so it is industrial produced. So that means inside a factory, not on the job site. It is a pre-stressed system with strands and wires. So we don't use any rebar whatsoever. It is a self-bearing product. So as you can see in the picture on the right, you can see that it is self-bearing. We still use struts from time to time to align all the slabs in height so that you have an even surface on the ceiling. And we can go large spans up to 19 meter with a much slimmer product, a much thinner product than the traditional cast in situ if you would have to do the same spans. You can go even bigger as that. So to make a small comparison between Holocore floors and other systems, so all flooring systems, so we have the Holocore floors, which made with rebar. So this is the reinforced Holocore slabs. This has a maximum span of 7 meters, thickness between 120 mm and 180 mm thickness. The width comes in different size. It comes in different sizes. We have the largest is 0.6 meter, but also made in 0.3 meters, so 30 centimeters. Then the pre-stressed Holocore slab, as you can see, it stays there 20 meters. Like I said, it can go even bigger than 19. So 20, 22, 22 is pretty much the maximum. And this comes in a size coming from 12 centimeters thick up to 50 centimeters thick. Widths, again, like I said in the beginning, we have 0.6, and we have 1.2, we have 1.5 meters, and we have 2.4. It doesn't mean that if you buy a factory that you can do all these widths. Standard, it's always 1.2. If you have a 1.2 meter production facility, that means that you could also do 0.6, 0.6 next to each other. Then we have the TT slabs. This is a maximum span of 12 meters. Thicknesses are between 17 centimeters and 35 centimeters. And the standard width of this product is 2.4 meters. And then you have the bigger T's, of course, more for industrial buildings. This is 24 meters, but there you see that it goes in between 20 centimeters thickness up to 80 centimeters thickness. That's a big difference, of course. Widths are variable in this because this is made in molds. It's 2.4 to 3 meters. Even bigger exists as well. Not done very often. And then another popular product is pre-stressed planks or a pre-stressed slab, a solid slab. Maximum span here is pretty much the same as the reinforced Holocore slab. This is about 6 to 7 meters. Thicknesses between 10 centimeters and 25 centimeters thicknesses. Widths, again, this is made on a table or a mold. Very variable, 0.3 to 0.6. Bigger exists as well, but more difficult to handle, of course. Another popular product is the Filigree Slab, so the Lattice Girder slab, like we call it as well here in Europe. This has a span of about 7 meters, can be either with reinforcement or with pre-stressed. Widths are different. There are much differences in this because it's again made on a mold. So that is the main difference in flooring systems made in a precast environment. Holocore slabs has, of course, quite a lot of advantages. We have efficiency, sustainability. It's much faster for installation. It's safer. It's easier. Holocore slabs have been designed to be easy to install, easy to implement in designs, and easy to fabricate as well. And it's a very versatile product. We'll start off with the efficiency. The efficiency is mainly on the products you use. Anything with precast, it's about the products you use, but also the efficiency in labor you have. As we are working in a factory environment, that means that everything is everything is controlled from a factory. So you have much more quality reassurance. You know that the concrete has a certain level of quality. You know that you use X amount of cement powder. You know that you use X amount of stones, X amount of sand and other materials as well. Compared to traditional slabs and Holocore slabs, because we also are hollow, it's a hollow slab, like the name says it, we use 45% less of raw materials. Also, the weight goes down with this drastically. We use less gravel, we use much less steel because again here we are using pre-stressed wires, so not rebars. We use less cement because we work with a dry mix, and also the water consumption goes down. Compared to precast in general, we have concrete consumption goes down by about 20% compared to the cast in situ. We have also less steel consumption, about 30%. This is in general precast. So also about lattice girder slabs, etc. And you also need less manpower because we can go for higher automation. Even with a low level automation, you still use less manpower. Like I said before, we use a drier concrete. So we use zero for Holocore. We use a zero slump concrete. This has about 300 to 300 kilograms of cement usage per cubic meter of concrete. The cement type we recommend is a 52 C52 rapid cement. This can be other types as well, but to have a much more efficient production, we recommend that. If you look at a wet concrete mix, you're much higher. You're 400 to 420 kilograms of cement powder per square meter. So it's a big difference there. And in the end, cement is one of the key factors in price. Sustainability, another point. So it has a longer lifetime. So a longer lifetime, the cycle of buildings. Second, destination ability. So that means that if you build with a Holocore, you can make big spans. Let's say an office building, your building, you can have big spans, big open spaces. In this space, you can still put small walls, non-structural walls. Afterwards, if this building will get a new destination, you can completely tear it down and change it up again without having to change the complete structure of the building. Per square meter of floor surface, you have less city traffic. A lot of cities worldwide are implementing that job sites can only have X amount of traffic. London, for example, is a good example there. They actually insist to have more how to say precasts implemented in job sites. I see there's a question there. The thickness of the T inclusive of the bottom of the T or just the flat slab section? Though this is including. So the T slabs, this is everything included. So I'll go on. Less people on the job site. Like I said, installation, mainly in an installation of a job site for Holocore or precast in general, you see about 5 to 10 people on the job site. Also for very large job sites. Everything is hauled in with a crane. So everything you do is installed with a crane. You need 2 people to install one Holocore slab. These 2 people install the Holocore slab all over the place. Less waste thanks to the better quality control. So this means, again, factory environment, you have much more control about the quality. And this is a big key factor. Less consumption, dry concrete, optimum use of cement and other materials. So like I said earlier, you use less cement. Cement is environmentally less friendly. This is why less consumption is always better for everybody, not only for the environment, also for your wallet. Cradle principle. So that means that you can completely recycle the building. So you can tear it down and recycle it completely and reuse actually the recycled material. A use of thermal mass activity. This means that with concrete, you have a much better efficiency of heating the building or cooling the building. And a slender product, so a much thinner product with a high strength of concrete. This again, you can see in the big spans we can achieve. Sustainability is, like I said, environmental friendly. Pre-stressed Holocore is an environmental friendly precast product. Any precast product is more environmental friendly than doing cast in situ. Speed, fast and simple. The principle, like I said before, about being fast and simple. Increased construction speed, so you can be much more efficient in your construction. So tomorrow I need let's say 400 square meters of Holocore floor slabs. So which day you need it, and that when it's shipped out, it's going to be installed and everything. So you have a much more efficiency. You can also be much faster in installing it because you have less people, also less people to take in account when having a production site. Reduced weight. So Holocore, like we said, it was 40% lighter, 45% lighter. Self-bearing, so you need no props, only for aligning the slab, so small props. So that also means that you have a much cleaner job site. Flexibility, we cut the slabs on length for the job site. So a Holocore product is not a product to put in stock. Holocore product is tailor-made. So that means if you have a building that needs 17.22 meter slabs, you make it 17.22 meters. Then the next slab needs to be 5.68, you make it 5.68, and so on. So everything is tailor-made, is actually made is made to the request of the client, to the design of the building. Spans, so the performance, great span versus depth ratios. That means compared to a cast in situ or any other product, Holocore slab, we can achieve a great span, as we saw in one of the previous slides. We can go up to 20 meters slabs, and we have the maximum height of 50 centimeters. 50 centimeters is also the maximum height possible to make with a Holocore slab. So if you compare that with a TT slab, with the big T slabs, you're about 80 centimeters, 800 millimeters height. So it's a much more slender product. So the performance is much better. And then you have less site personnel needed. So again, cleaner job site, like I said, much more efficient. There's a question about how safe is it to demolish pre-stressed structural members. So I suppose that you mean completely demolish the complete structure, or is it then more about demolishing the only one section, for example? Because demolishing any building is a very it's not a safe job anyway. So we have to demolish with care always, but it comes down. You have to take it apart like Lego. In the end, the principle of Holocore is of precast in general is the same as Lego. You start on the top and go back down. You start on the bottom and go back up. Safety, fire resistance. So Holocore slabs are known to be very good in fire resistant. It doesn't mean that if there's a fire that that the Holocore slabs will stay intact. They will stay in place. So the fire resistance can go from 1 hour up to 3 hours. This is very dependent on where the rebar is located in the slab. So we can change in the machine itself the wire location. So that means that you can make tomorrow one complete bed with a fire resistance of 1 hour, and then afterwards you change inside the machine some parts, and then you can go up to 3 hours because you have much more concrete coverage. Safety, like we said before, safety. Holocore slabs work together when connected. So in a building itself, so as you can see here, the little picture is a skeleton frame. Holocore slabs actually are all single slabs, but when you connect them, so when you pour a topping layer, or even without a topping layer, you just grout in between the slabs, these will act as one complete solid slab. So there are single parts connected to each other. The connections are made with the rebar connected to the sides of the buildings, and are I would say, and are also inside. You can also make hammerheads, so openings in the slabs, and connect the slabs in each other with hammerheads. So as you can see here, and the safety, we see here on the right picture, you see actually the connection. So this is actually the grouting layer. So you connect with concrete, you connect them together. I'm just going to look because there are quite some questions coming in actually. There was somebody asking if the planks retain rainwater within the hollow sections. Are the wires prone to corrosion within its lifespan if not drained? So Holocore is a concrete product which is hollow. You always have to have a layer which protects against rain. When producing in countries where there's a lot of rain, when producing, for example, here in Europe, what we have is drainage holes. So there are always small holes in the Holocore slabs on the bottom where water can go out again. So that means that these have to be done in the production. We do these with a plotter or with just a simple drill, actually, when the concrete is still wet. So you always have to cover it like a roof afterwards. If you use it as a roof, you have to cover it with roofing or any other material. Then there's another one. Do you not allow flexibility to cater for site production dimensional errors? Must the construction be perfect, or may there be measures on site before production? If a structural member is pre-stressed, can it be broken safely? Look, normally the normal process of producing the Holocore slabs is that you have a structure, and that you with precast, you know that if you have a structure which is completely in precast, you know that the structure will be within a certain tolerance, and then there's no problem. When we're working with a conventional method of construction, it also allows some deviation, of course. There's some tolerance, which every single building code has worldwide. Um, but the you always have to take care of. There are always sometimes issues on job sites where people will make a mistake and their measurement is wrong and things like that. We cannot do a production on the job site. What you can do, of course, is if the slab is too long, you have to take it back to the factory, cut another piece off. But that's not why you would use precast. You need to take in account a certain margin. The support, for example, on Holocore on a normal floor is about 7 centimeters on both sides. So that means you have 14 centimeters to play with, left and right. The minimum worldwide, what we see is about on support is about 3-4 centimeters. That's the absolute minimum, which is not recommended as well. And then you need to use struts to make sure that it will stay up. So yeah, if a structural member is pre-stressed, can it be broken safely? Yes, it can be broken safely, but yeah, breaking off a slab in the middle of a building is never going to be easy, however you do it. So I'm not sure how you see that breaking it safely. Can these products be set available at a hardware shop? That's a more difficult question because that depends really on the building code you use. The building code here in Belgium allows, for example, for sort of a standard product. So we have here a standard range of products where we can use this. So here in Belgium, the code allows it. It also is a sort of a standard that a standard slab is 6 meters, for example. So it depends really on country to country. This is something we should maybe later on discuss in more detail because I can go on and on about this topic. So somebody also asked if future large penetration are required, say mechanical cutting, what are preferred methods of strengthening to the productive structure? In a Holocore slab, so the strands are in length direction. Most of the time, what the best thing to do if you have to make a cut, hope you can see my mouse, is that you actually make a cut in the hollow section. As an example, my house here where I live is also built with Holocore. All the tubes, all these things are cut in the hollow cores. So whatever openings for let's say drainage is made in a hollow section. It can happen that somebody cuts in a strand. Normally it can take it. Of course, if you take a Holocore slab to its absolute limit, then you will have an issue, of course. It's versatile. So to go on with the presentation, it's versatile. Where can we use it? Pretty much everywhere. It's as simple as that. Holocore slab is actually made for pretty much every possible use you can imagine as a flooring system. It is very popular here in Belgium for residential housing. Like I said, my house is also built with that. Social housing, because you can produce it in mass. Industrial products, because we have the high loads. Offices, because of the big spans. High-rise skeletal structural buildings. High-rise load-bearing wall structured buildings. Park houses are very popular products for that because of the high capacity. And stadiums, again, big spans. To give you some examples, this is a residential house, a typical design for a residential house. You can see actually inside, you can see this is a Holocore slab that has been used here. Here you see it in different direction. Some people, some architects sometimes mix it up that you have a Holocore slab next for it's a half slab. So everybody has their way of building these things. On the right picture, you see a picture of the inside of the house with exposed concrete. So a Holocore slab is also very nice to look at. For the more modernist architecture, a lot of architectures like this pretty much. Social housing. So here on the left, you see pictures of housing here in Europe. And on the right side, you see actually this is a project made in the Philippines. So it's a very popular product there as well to make in masses. You can make it in industrial buildings. On the left is a picture actually from a prison. So here you see the big spans. And you see also, so this was also a building which needed high loads. but you also see that you can make it to the shape you want. So the shapes, they're not rounded as the building, but they're going to be straight cuts always. But everything is possible. So with a multi-angle saw, you can do all degree of cuts you need. Here you see another office building which is constructed here in Europe. On the right, you see actually a building that was in Asia, if I'm not mistaken. So on the right is a picture of the inside of an office. As you can see, big spans, so you can put all the walls in. Another example of such a building. On the left, you see a parking house. In the middle is a new office was being built. The right is also the same. And then high-rise skeletal construction. So you build a skeleton in precast, and also then the flooring is made. The building on the left, if I'm not mistaken, is about 35 stories high. And here you see high-rise load-bearing wall structured building. So that means that you have the walls in precast, which are load-bearing, but then you have the floorings, the Holocore floorings that are placed on top of it. And park houses. A big market for Holocore is the park houses, so the car parks, because of the big spans and the high load possibilities. As you know, you want to cramp as much possible cars in a car park as possible, and you want to have the biggest load possible. So the more space you can have, the better. The more structure you have to place, the worse, of course. So the big spans here you see on the picture that you see from the first cone to the other one for structure is one Holocore slab. And then stadium grandstands. For this, we actually have a special product called stadium plates. As you can see on the right, you see plates being placed in sectionals, and they're being placed on top of each other. So they are being produced like you see it there. One slab has a little notch on the edge, and then you can actually place them on top of each other. On the left is a picture from a job site in Australia from a customer of ours, where this is quite a popular product for them. And then here's a little movie where we have, this is from an Irish customer, Keach, who is using the system of Holocore slabs together with load-bearing walls. So as you can see, this is open spans. And you can see the Holocore slabs being placed on top of it. And then they use a connection system with load-bearing walls. So this is the connection inside. And then you can, as you can see here, you can make openings in the slabs with supports on the other slabs, because this works as one unity, and you can use the other slabs to support the slabs to put, for example, staircase. So here you see this is the connections itself. So this is rebar being placed, and then there's a small topping layer being poured over it, not over a complete slab, but over the edges actually, to connect, to make it one big, huge slab for the building. Earthquake resistance. So this is a big topic. Like I said, Holocore is a slender product. Holocore is a thinner product. Holocore has a lower self-weight. The force equals the mass times the acceleration. So because you build much lighter, that means that there is also much less mass in the building. So that means that there's much less movement in the building. And that also means that your foundation work will be much lighter than what you used to be. And then the use of thermal mass concrete. So we have a special product here, which we produce with our slip former. And this is a Klimadeck. The Klimadeck is actually a system where you have heating tubes inside the concrete slab. You can use these heating tubes for either a house or also for offices. And this is, it's very efficient because you use the strength of the long spans, but you also use the ability to make a more slender product than you have to put it in the floors again. What does it take to make a Holocore factory? I'm just gonna see there's another question coming in. Once a building gets pressurized with air conditioning, how do the precast panels react to this different air shock? It's concrete. There's no shock whatsoever on that, or pretty much none. For example, a good example is the Middle East. In the Middle East, it's quite hot, as everybody knows. There, the people actually, air conditioning inside is about 22 degrees. Outside is 40, even more degrees outside Celsius. There's there's no issue whatsoever with cold shock or other things. Then another question: will there be more sound transfer to the area below? Yeah, Holocore is a product known for because of the Holocore, so that it is soundproof, but it is indeed there is more echo inside of a building, but this can be solved with other solutions. To go on, so a requirement for producing Holocore. When you produce Holocore, you need a factory. So the inside of the factory building, this is something we will supply. We can supply with everything you need. Here is a little render where you can see a long line production, how it looks like. Typical length of a bed is in between 100 and 140 meters. The most factories we set up are actually 120 meters. You don't want it to be too short because you also have preparation time, but you also don't want it to be too long, because if it's too long, you have to cast the same slab for one complete casting. So that means that you have one slab of a specific height with a specific wire pattern with a specific load bearing capacity that you produce in one go. What can we produce in such a factory? We produce the Holocore floors. We can produce smaller floors. We can produce bigger floors. We can produce also Holocore wall panel, which works as a facade. It doesn't work as a load-bearing product, but as a facade. We can also produce foundation piles. So it's a quite limited application here, but we can produce foundation piles. And then we can also produce beams, so bigger beams, as you can see on the right. These can be used in a roof structure. We can produce U-gutters. We can produce, then of course, the stadium plates like you saw. But also a very popular product is the T-beams, the small T-beams, inverted T-beams for some of you guys. These are used in housing. These are about 17 centimeters height maximum, and these are quite light actually. So this is a product you can manage by hand on the job site. It is quite still heavy, but most of the time it's about 25 kilograms per meter. So still a rather light solution. Our production machines. One machine, a slip former. A slip former is a machine which has the most versatility. So a slip former, we can produce Holocore, but also the other elements. So the products I already discussed a little bit, but also what we have is we have lattice girder floors, pressurized lattice girder floors. This can be either a solid slab, or this can be with lattice girders on top of it. This can be also E-slabs where you can put insulation inside. Things like that we can make. As long as it is pre-stressed, we can pretty much make it. We also have possibilities, like I said, to make beams. These beams go from about about 15, 20 centimeters high to about 50 centimeters even, to make the more higher load beams. Small T-beams, like here we see it in the picture on the slide. These go up to 15, 17 centimeters, pretty much the highest that we make. Vine stakes we can make window lintels, we can make guttering, and then the foundation piles. Then the other production machine which we use is the extruder, so to extrude the concrete. This is a flow compaction, so this is the newer generation of shear compaction. This is a very reliable machine because there are less moving components, so that means that there's less maintenance to be done. The main parts that wear out are screws to extrude the concrete and wear plates to shape the concrete. We can make slabs from 50 centimeters high up to 50 centimeters high. And we make them either in an 8-core configuration, so that means 8 holes, 6 holes, 5 holes, or 4 holes for the bigger ones. The other machine is the extruder. What makes it so special to that it is a flow compaction machine? This was because we use sharp screws inside the machine. So this is a patented sharp screw and is a highly competitive screw. And this I mean that on speeds. So the speeds will increase with this type of screw. We have the complete control of the concrete flow inside the machine. We can also make it run fully automatically. And this is a machine which is easy to clean and to run as well. So the operator as well, it is as simple as a phone, as an iPhone or an Android, whatever. So you can push on the button, start, the concrete goes in and it goes. Then after the concrete is cured, then of course you have to cut it on size. Like I said, we can make it in different shapes. We can make it with angles. We can make it on the length required. And this we do with our sawing machine, which is a very big machine, but also a high-tech machine. And this cuts slabs up to 50 centimeters in height. We can even automate it to a point that it's running on its own, together with our plotter. And this machine is a tool you need in your factory. The aspirator is a machine which gives you more efficiency in the factory. This helps you to make openings, as you can see in the picture. This is an opening for reinforcement, and also so mainly for reinforcement, but also, for example, for a beam which passes in the structure that you have to make an opening for. Then the machine, which I said before with the sawing machine, the plotter. So this is a machine which replaces a laborer of two guys that make the markings on the slabs for the length. And this is a machine which runs fully automatic, no operator, as you can see on the top picture. It runs on its own. It doesn't make any mistake because it follows the drawing, and it is connected over Wi-Fi to your server in the factory, and a battery-driven machine, of course. And then we have also our concrete delivery system. The concrete delivery system is a system to supply the concrete in your factory. On the picture on the bottom, you can see there's a production machine. This production machine needs to be filled with concrete. The conventional method is that you have a bucket hanging on the crane. You bring it to the machine, you dump it. And then the way to do it to be much more efficient is with a flying bucket, which drives from your batching plant up to your production machine to a portal system, which then takes the concrete, brings it to the machine, and dumps it in the machine. And this we can make highly automatic, or with a semi-automatic setup. So what is there to bring in this industry still today? More and more automation. I think more and more of you guys are also, well, people who are producing anything, whatever it is, you want more automation. So Industry 4.0, it is something that more and more is coming up. It is there, but it's still not where people want it, I guess. But it's also about connecting all the machines together. Everything needs to be interconnected with each other. And that is what we do. We have a system called Stables. Stables is a system which is used also with AOA factories, but also with our machines. And this is to connect the machines. So you go from the planning towards a server. This server also has this data ready for the machines. The machines transmit data back to the system. You can get statistics from the system. You can also get statistics from the batching plant, and so on. That's about it. If there are any other questions, always welcome to ask them to me. You can send them directly to me as well. These are my contact details, or you can also contact us over general email, which is info@ecoprecast.com.
Thank you very, very much, Mallory. We really do appreciate that. I just want to say thank you to our attendees too, and of course to Rakesh, Skulk, and Chinadam for making it so very interactive with those fantastic questions. It was definitely an informative presentation. And just our sponsors, PMSA, for making this all happen. And I'm sure all the attendees have loved all the presentations from PMSA. And yes, with that, it's an absolute wrap for our workshop program. Thanks everybody for joining, and we'll see you again soon. Thanks, Mallory.
Thank you very much, everybody. Bye-bye.
Bye.